bin. And there's a way to, yeah, there we go. So I'll just give it a couple minutes and then we'll get started. So
yeah, I'm really excited to hear the students' questions and yeah, just provide as much insight as I can to kind of help inform their next steps. To really fascinating area, and it's cool to see young people excited about the brain.
yeah, and neuroscience is definitely one of the most popular topics here at Polygence. So and just talking to, I've interviewed a lot of students, but it's so much fun to sort of hear their questions and sort of their curiosity about the field. And but it looks like we have 11 people that have logged in. So we'll give it a few more minutes here while we let everybody get logged in, and then we'll get started. And Raul, just to confirm, can you see my screen here?
Yep.
Cool, awesome. All right. So we'll go ahead and get started with the webinar. So welcome everybody. Actually, before we get started, what I'd love to do is if everybody wants to, in the chat box, if they want to just let us know where you're from, just tell us where you're logging in from, and just to kind of get us started here. I'm from Rochester, Minnesota, so been here for 6 months. Moved here from Austin, Texas. So what about you, Rahul?
I'm calling in from Durham, North Carolina, and I originally grew up in Jersey. And I'll talk about it a little later. That's where I went to school, but I also lived in DC and the San Francisco Bay Area too.
Awesome. Yeah, definitely. I imagine it's a lot less expensive to live in Durham than in San Francisco.
Any of the other places. Any of the other places.
Yeah, totally understand. Actually, Rochester is quite a bit less expensive than Austin, Texas. So looks like our chat is disabled. So my apologies. There's a way to enable that. So bear with me for a second while I go ahead and there we go. Try the chat one more time. Let's see if you're if the chat works. Had this issue a couple of times, but feel free to let us know where you're from in the chat box. Maureen logging in from New York.
It looks like Lisa's joining in from New Jersey, so Lisa's a lot of Garden State pride.
Awesome. The Northeast, fantastic. Got California. Which part of California? All right. You got Houston, Texas. Love Houston, Texas. Definitely traveled there a lot when I was in Austin. All right. Got some more California, Bay Area. Yeah, I imagine we got probably a lot of Bay Area folks. So awesome. All right. So we'll go ahead and get started. Hello, everybody. My name is Christopher Jack, and I'm one of the partnerships managers here at Polygence. I want to welcome everybody to our Ask Me Anything with Rahul Patel. He's going to talk about his experience in the neuroscience field. And here at Polygence, we've been around for about 4 years now. I think we're going to hit the 4-year mark as an organization in April. And we've had over 2,000 students who have enrolled with us here at Polygence and have completed a research project. And what's so interesting is neuroscience tends to be one of the most popular fields and one of the most popular requests for projects. And what's so interesting is in our conversations with a lot of students who are interested in neuroscience, many of them are sort of new to the neuroscience field, and they have a lot of questions about sort of what is neuroscience, what does a career path look like for neuroscience. And so really the webinar today, the intention is to really provide some more context as far as what the neuroscience field looks like and sort of the career paths, and also to talk about why mentorship is so important as you're sort of looking at potentially moving into the neuroscience field. So the way this is structured is, Rahul will provide an introduction. We're also going to sort of cover an overview of neuroscience and the field. We'll also talk about Rahul's journey from high school to now a PhD candidate in neuroscience. We'll also dive into sort of the impact of mentorship, not just for Rahul, but also for students here at Polygence and the mentees that he works with. And for those that are interested in sort of further pursuing neuroscience, we'll also talk about the next steps as far as sort of potentially moving into applying for a neuroscience program at college, or if you're interested in maybe doing a neuroscience project here at Polygence. So the way that this webinar is structured, this isn't Ask Me Anything. So we're not going to designate a time at the end for you to ask questions. So this is more really designed to be more freeform. So absolutely, at any point, if you have a question for Rahul or just sort of a question in general about neuroscience, please drop that into the Q&A. The idea here is to sort of have some prompt questions that I'll be asking Rahul throughout the webinar, but certainly at any point, if you have a question, don't be afraid to chime in and just drop that question in the Q&A. We'll definitely get to that as soon as possible. So again, encouraging everybody here, if you have a question at any point, feel free to drop that into the Q&A. So without further ado, I'd like to turn this over to Rahul to talk about his background and to introduce himself.
Yeah, thank you so much, CJ, for kind of outlining what we'll talk about today. And I just want to thank all the students for joining us. I think one of the best parts of Polygence is really the interactions I get to have with students, and I'm excited to tell you guys more about me. So I grew up in Jersey, as I mentioned before. In high school, I really got introduced to neuroscience pretty serendipitously. I'm a huge fan of movies, and in the early 2010s, essentially, a series of really great movies came out about the brain or brain adjacent topics, essentially, whether it was Alzheimer's disease or learning and memory. And as someone who really enjoyed the process of learning and had so many questions and curiosity about how learning happens, I started to think about it'd be really cool to have a career where I could understand how the brain works. So when I went to college, I studied cell biology and neuroscience at Rutgers. It was pretty close to home. It was about 15 minutes from my parents' house. And it had a great research program too. So it seemed like a great fit. And I had a great time there. Learned a lot, gained a lot of great research experience that helped me eventually transition to my PhD program at UNC Chapel Hill. And thanks to some great mentorship I got to really explore several different research areas within neuroscience. And it's been a lot of fun to actually work with Polygence students on some of these areas, whether it's Alzheimer's disease, pain, which is my current research interest, learning and memory, and kind of throughout my career, I've been very fortunate because of the mentorship I received to also perform internships and experiences beyond the universities that I'm a part of. So I'm a big proponent for public education and education initiatives in general. So in 2016, I was an intern for Society for Neuroscience, which is the largest neuroscience society in the world. There's about 35,000 neuroscientists that are part of the society. And I was a public education intern essentially for that office, that organization. and this was while I was in my bachelor's degree. After I graduated college, I worked at Stanford for some time prior to starting my PhD. And during my PhD, like I said, I've mostly been interested in pain, and my thesis involves developing machine learning approaches and engineering solutions to measure the emotional part of pain in animals, essentially based on their facial expressions. And throughout my research, I've been pretty lucky to have some awards from the government. The National Science Foundation has basically funded my entire PhD, and I've gotten some scholarships from the National Institutes of Health too to support some learning opportunities. Again, all of this is really not because I'm very smart, but a byproduct of really great mentorship I received and guidance through each of these career stages.
Awesome. So I'll jump to the next slide, because I think one of the questions that often is asked by students and counselors and parents is, what exactly is neuroscience? Can you sort of talk more about how you would define neuroscience, and also what are sort of, because you talk about pain and Alzheimer's, can you talk about sort of the subject areas within neuroscience?
Yeah, absolutely. So neuroscience broadly is the study of nervous system, whether it's the central or peripheral. So when we think of the central nervous system, talking about the brain, sometimes even I forget that the spinal cord is a component of the central nervous system. And in the periphery, so outside of those two central units, you have lots of nerves that innervate or control essentially muscle groups, other organ systems. The nervous system in general is just this really unique organ system that interacts with everything else essentially. It really works in beautiful concert with the rest of the body to achieve some of the things that we often take for granted in our day-to-day lives. Just like I'm scratching, my eyebrow just now, right? That's a combination of both, a sensation I had on the hair of my eyebrow, and there was probably something that went off in my brain. I said, there's an itch feeling. You should take care of that, or just like put a motor stimuli on, or sensory stimuli on the eyebrow, and then a very simple touching my eyebrow action happened right as a result. And there's a lot to unpack there, right? So broadly, the study of the nervous system. How do you actually study the nervous system? I'd say there's several different subfields within neuroscience that work to achieve that. And there's exciting different career paths that one could take to enter each of them. So some of neuroscience is very much traditional biology. So you have folks that come in with biology backgrounds, ranging from genetics to molecular biology. There's a lot of neuroscience programs out there now too, that combine coursework in psychology and biology into a kind of 4-year college degree, essentially kind of what I did. My degree kind of focused more on the biology, however. And the traditional biologists, when they enter neuroscience, they approach it as from the lens of how does the nervous system develop, sustain its function, and how do those processes go awry during different diseases, whether they're neurological or psychiatric. So we can think about Alzheimer's, depression, anxiety, any of the kind of diseases or disorders in that space too. And there we really rely on biological tools. So what genes and proteins and things like that are important for, again, the health and disease state of the brain and nervous system. There's another group within neuroscience or subfield, which concerns different parts of the nervous system and how they communicate with one another. This you could call circuit or systems neuroscience. So it relies more on the study of the activity of different nervous system units, whether it's central or peripheral, and how that can be integrated into behavior, essentially. So if we know that a certain brain area is really important for language processing, and we want to know, where do stutters arise from, for example. One could study that brain area and identify when someone stutters. Is there a specific location within the brain that controls that? And could that information then be used to understand how language more generally is processed, and individuals with speech pathologies, can we use that information to then improve their outcomes? So you can see just off of that, right? Two very completely different questions in many ways, all within neuroscience, which is, what are the building blocks of the nervous system from a biological perspective? And then what are these almost emergent properties of the nervous system that relate at a more macro level to behavior? And within those two major fields, I would say you can also take the lens of wanting to work with animals versus people. So that's another dimension. I hope this kind of just highlights that there's quite a few different ways to be a neuroscientist as a result. So, and that's what I think is actually quite exciting about the field. So you can take a, computer science math major and they can get a neuroscience PhD very well, actually. You can take a biologist or a psychologist, and they can also become great neuroscientists. It's a field that really integrates a multidisciplinary approach. And I think that's what really is exciting about it from an education perspective. You can be an engineer and transition to neuroscience. You can do both if you wanted to. For me, I came in more as a biologist and became more computer science and engineering focused during my PhD. So it's a field that you really never get bored in the sense that you're always learning new things, because it's cool that we're using our own brains to understand the brains of other organisms or other humans, right? In some ways. So it's a very exciting field to be a part of as a result. And some of the things that you learn sometimes are directly applicable to your own life, and can even your own lived experiences can inform your research as a result. And now that there's heightened interest and awareness, thankfully, for mental health, I think the field is experiencing tremendous growth as a result. People, positions in neuroscience for research are continuing to grow. The private industry, so pharmaceutical companies are starting to have additional interest in neuroscience again. And also a lot of big tech companies also hire neuroscientists. And some of my students have actually transitioned to more data science roles after doing neuroscience, or even business roles. So, neuroscience is one of those things that if you talk to most people about, they get really excited about it. And there's great career opportunities after you get a neuroscience degree.
So we have two great questions here, and I want to get to those in just a moment. And these are actually going to be related somewhat to the next slide. But one question that I get asked pretty often when talking to students that are considering doing a neuroscience project is do you have to get a PhD in neuroscience, or does it have to be something where your career path is really focused on sort of becoming a faculty member at a university? And it's a tough question to answer because there are so many career paths within neuroscience. What are some, in just sort of like practical jobs that you could get with a neuroscience degree, especially whether it's a master's or a PhD?
Yeah, so that's a good question and totally valid question. I'd say that now there's actually, I'm finishing up my PhD at the end of this month. And from the statistics I've been made aware of, a minority of students actually, after they get their PhD, continue in academic research. So the traditional path to become a faculty member, that's actually not what majority of students are pursuing these days. I think some of the really exciting things, practical things that folks are pursuing after getting a master's or PhD in neuroscience kind of includes data science in many ways. the amount of data we generate when we do most neuroscientific studies these days is orders of magnitude higher than it once was. The days of being able to go into Excel and run your statistics or analysis on your neuroscience experiment, every day that goes by, those days are becoming numbered. Programming is going hand in hand with neuroscience these days. So I've seen a lot of my colleagues transition into data science and software engineering roles after they get their master's or PhD. And because they have that doctoral degree or advanced graduate degree, they do start off at a different career stage as a result. And the compensation obviously follows that. I've also had students of mine who did their bachelor's degrees in neuroscience, and they go on to pharmacy school or medical school, or I've had one student go on to actually become a consultant after doing neuroscience in undergrad and doing research with us. And that's another thing that I'm still, I have some colleagues in the last couple of years who have graduated and gone on to business facing roles after doing neuroscience PhD. And then of course, the traditional opportunities in the pharmaceutical industry are still there as well. And there's so many exciting startups, especially in the Bay Area and Boston, San Diego too, where you can go and work in industry after getting your advanced degree in neuroscience and apply either if you're, I think now it's more of a hybrid. A lot of neuroscience PhDs have both experience in biology and computing and engineering. So they really become very unique individuals in different organizations because they're trained to think in a very interdisciplinary manner, if that makes sense.
That's the word that I hear pretty often with neuroscience is sort of interdisciplinary. And I do want to jump to Lisa's question. And she asked, what was your role at Stanford? And is it true that you can increase neuroplasticity by standing on one foot? So those are some pretty interesting, actually great question there.
Yeah, so I was a researcher at Stanford. So I had the privilege to work in a lab that was interested in multiple sclerosis, essentially. So I was helping them with their research efforts in that domain. And it was a lot of fun. Great lab that I worked in. And the Bay Area is a lot of fun too. A lot of good research there. And with regards to neuroplasticity, yeah, that's the cool thing about neuroplasticity. So I don't know about that example in particular, but in general, there's so many little things that anything that you're doing to learn essentially a new skill or new information every day, in many ways, that is neuroplasticity at work. For example, something odd about my experience in graduate school, I'm still pretty clumsy, but I read something about how the part of the brain, the cerebellum, so the back of the brain essentially, is really good at motor learning. And I started reading and learning more about this and this idea of there's something called an error signal, which basically when you try to execute, if I want to touch my camera and I miss, an error signal will go off in my cerebellum in some ways and other parts of my brain to say what you aim to do versus what actually happened didn't match. And that error signal is what helps us refine motor commands and learn essentially. In some ways, that's neuroplasticity. And I don't know why, but after learning about that, I became way more cognizant of it. And I'm still very clumsy to this day, but I don't drop things anymore. So I'll knock things over all the time. I can catch them out of midair now. Something that when I started my PhD I couldn't do. So neuroplasticity, even as you're learning new information today, like in this call, you're having some neuroplasticity occur as a result.
So growing up, when I was bad at sports, it was just all error signals. I couldn't catch the ball because there's a great question, Lisa. And Maureen had a great question, but I wanted to jump into the next slide because this is actually directly related to Maureen's question. Ro, I'd like you to talk a little bit about what got you interested in neuroscience in the first place? And also, if you also want to jump in and talk about the classes that you took in high school and throughout college.
Yeah, absolutely. So what got me interested in neuroscience was um, I was always a very curious kid. And one of the things that always sparked my interest growing up was how people learn, essentially, and differences in learning and how that actually occurred at scientific level. Um, and it wasn't until I watched a few movies. There's this movie with, I think, I forget the actor, Bradley Cooper, maybe. It was called Limitless,
Hmm.
and it was this idea. This like normal guy happened to, um, you know, it was rooted in the idea that essentially that you only use 10% of your brain, which isn't true. Um, but basically, had access to, he was able to access like all of his brain, and it changed his life essentially. He became super smart and he could remember everything. And I just remember thinking like at the time I didn't know that the 10% thing wasn't true. Um, I was like, oh my God, wouldn't that be awesome if we could use all of our brain? And then, I quickly Googled like, why do we only use 10% of our brain? And it turned it out that that wasn't actually true to begin with. Um, but that kind of sparked my interest in neuroscience more so because I was like, oh, like if we do use all of our brain, why are there individual differences in memory or learning or any of these things? So that's what started getting me thinking about neuroscience and the kind of class I took in high school. I took AP Bio um, and a lot of STEM anatomy and physiology courses too. Um, I think I gravitated more to biology um, early in my kind of education. So I think AP Chem, physics, all those classes helped too. Um, I would say like now the way that neuroscience is moving, it's very math. It's becoming more and more math heavy. So I'd say like statistics is a really important class. If you can learn how to program and taking programming classes in high school, that can be helpful. Um, and it's interesting. I was kind of when I was in college, that's when I started to notice the shift in neuroscience away from pure biology to integrating more computation and math essentially. So in my major and undergrad, I had, my neuroscience courses, I took biology courses, chemistry, physics, um, all of those things. But on top of that, um, as I noticed that things were moving more math heavy, I actually started taking advanced statistics courses and programming classes as a result. Um, and that really, I think, prepared me well for my PhD essentially because uh, the statistics exposure was really helpful in kind of the work I did during or work I'm doing during my PhD because without that, maybe I would have relied more on my biology background as a result. Sorry, CJ, you're muted.
Yeah, I'm muted. um, so I'm curious, what coding languages did you focus on, or like, to start? Are there certain coding languages that you use primarily in neuroscience?
Yeah, it's a great question. I started with R, and it's pretty user friendly. Um, and now, so I started with R in college because of the statistics classes I took, and R is very popular in the statistics community. Um, During my PhD, I shifted more to Python. A lot of the things I developed were in Python. Um, and it was a challenging transition, but I think programming is one of those things that very much there's this critical juncture essentially in your learning process where things become less scary. And it's just important to know like wherever you are, you will hit that at some point essentially. And once you hit that point or juncture, things become a lot easier. And you still Google. I Google things all the time. Um, there's, I have to sometimes look over my code again and be like, oh, like, yeah, that's why I wrote this way. Um, and that's what's really cool about it. You're constantly learning and growing.
That neuroplasticity is so critical
Exactly. Yeah. It's
for coding. So
neuroplasticity on a daily basis. Yeah, exactly, CJ. Yeah. So I think, I would say for high school students, one of the cool things that you guys can do is like, if you're interested in neuroscience, is using kind of affordable computing. So like these like little Raspberry Pi devices, essentially, they're great to learn Python with, essentially, because and basic, electrical engineering and like some computer basics as well. Um, it's a tiny little computer that you can program to do a variety of different tasks and automate things, essentially. And there's so many resources out there on the internet to successfully use these devices. And I actually used them during my PhD research, believe it or not. Um, and I always have my students get some experience working with those devices because it's a great intro to computing and computer science.
that's great information there. We have a couple questions here. One from Swara, which I think is really is a fantastic question. It's about, I'll actually just read it verbatim. So you said that as mental health awareness grows, this can create more opportunities for the neuroscience field to grow. Can you give an example of ways that you see this growth in the field, such as job opportunities? And actually, before I give you the chance to answer that question, one thing we're seeing a lot of here at Polygence in terms of topic areas of interest is mental health. And students wanting to study mental health in different capacities, whether it's sort of the neurological aspect of mental health or sort of a cultural context of mental health. So this is definitely a pretty big topic here at Polygence. So great questions, Farhan.
Yeah, I agree. So what I've seen as kind of practicing neuroscientists, how the increase in awareness of mental health has impacted the field is that I think there's as people are more aware of into everyone having their own challenges with mental health, there's greater interest in research as a result, especially on the human side. I think people are really, if people don't have awareness about the challenges we all have essentially with stress and lived experiences, and we all kind of just brush it over under the rug, I think that in some ways can really limit participation in key clinical research in some ways. Um, but also because people are more openly discussing mental health, which I think is fantastic, um, there's increased opportunities for, I think, collaboration between neuroscientists and psychologists, essentially. So as people kind of seek out counseling and other services that can help improve their mental health, there's just more data out there as a result, right? And collaborations can be fostered to ethically, examine what are some new practices that can be implemented and synergies that exist between the clinical care of or clinical treatment of mental health and the neuroscience that underlies it. Also, it's kind of motivated a push from the neuroscience community to better, like I work mostly on, I'm more of a neuroscientist, right? So it's really motivated us to develop new ways to study emotion essentially in the lab, and more critically evaluate previous ways that we were studying emotions in animals and people too, to a certain degree. So as people continue to be interested in mental health and we as a community value and prioritize it, the research in many ways is publicly funded, right? So funding follows public interest in many ways. So that's kind of how I've seen it. It's really motivated, at least my research, to kind of rethink core assumptions and create new models and approaches to better understand emotions in a way that's better aligned with clinical readouts than what we previously were doing. I hope that does that answer your question?
That's a really yeah, and Sora said yes. So that's a really great question. about mental health and sort of that connection to neuroscience. And we're about the 30-minute mark here. And so there's a couple more slides that I wanted to get to, but I wanted to ask two quick questions related to sort of your journey. And one is about what you plan to do after obtaining your PhD, because this is right around the corner. I know that you're finishing up your thesis right now. And the other question I had was about just your experience at Rutgers and UNC, because these are schools that students here in attending the webinar might be interested in actually going to. And so just kind of in maybe 2 minutes or less, if you want to answer both of those questions.
Absolutely. Yeah. So for next steps, I'm really in the exploration phase right now. So seeing kind of what's going to be the best fit for my career goals, as well as, as I'm getting older, kind of, the next 10 years, what I want that to look like, essentially, from a lifestyle perspective. So I've really thoroughly enjoyed neuroscience. The last 10 years I've been in the field. I would like to continue kind of being in a role at the end of the day where I can continue being a critical thinker, innovator, a mentor to people. So I'm kind of exploring quite a few different options. I think that's kind of exciting about this education path. You have quite a few options after you finish. In terms of my experiences at Rutgers and UNC, Rutgers gave me so much of my formative experiences. I think I look back, especially as I'm writing my thesis, that there's the research going to an institution in general that has a lot of research opportunities. You're going to be well set up, essentially. And the reason is because research often closely follows with good mentorship, or should. And I had amazing mentors at Rutgers that really pushed me to become the best student and person in many ways that I could be. That's what I tried to do at UNC too with my students, and that's what made my time at UNC really special too. The students and mentoring them, and there I really saw kind of how the power of mentorship can have a strong effect on students. So, like I said, a lot of one student is getting her PhD in neuroengineering now after working with me. Another one's in pharmacy school. One's a consultant. One's a data scientist, and these are all people that worked with me for few months or years essentially when they were undergrad. So UNC really offered me the opportunity to mentor some exceptional students, and that really made that positive experience for me, that mentoring of young undergrads.
That's actually a perfect segue for the next slide, which is related to mentorship. And I'd love for you to talk a little bit about a mentor or mentors that inspired you. And you can talk maybe a little bit more deeply about how mentorship was able to help you in your professional development, not just in terms of the content area, but also just like from a confidence standpoint.
Yeah, absolutely. Mentorship was absolutely critical. So this is a picture of my mentor and I, Dr. Sesti, and we went to a conference, and he had some, and took a picture of this very nice site. Essentially, this is back when I had very short hair, and long time ago. But yeah, so Dr. Sesti was my research mentor when I was an undergrad. I worked with him for a number of years, and another person that comes to mind is Dr. Duffy. He was another really critical mentor who worked at Merck. So he gave me a lot of kind of guidance from the industry standpoint, and Dr. Sesson gave me a lot of guidance from the academic standpoint. And what they essentially did in tandem in many ways for my professional development was provide me with two different lenses of how to be a good scientist, essentially. One from the academic lens of how to publish papers and things like that, and another one from the industry and business perspective of how do you do science in a way that can actually have actionable impacts in the pharmaceutical industry. And I think what they did for me, which was critical, was they showed me a lot of kindness and generosity throughout all of this. I was a very green person, in the sense of I didn't have a lot of experience in these domains, and they provided me with a really safe space to make mistakes and grow and learn every day, and provided me with the honest and tact feedback to really facilitate my learning on a day-to-day basis. I think that's really what good mentors do, is that they help you become the best version of yourself day in, day out. And I'm not sure if I should segue into how that motivated me to become a Polygence mentor, but I can answer some more questions about the mentors I've had if anyone has any questions.
Yeah, there's actually a great question here by Anika. And the question is, what are some tips you learned in regards to writing research papers? And I think that's actually a great question because I imagine that your mentors probably had some influence in how you wrote those research papers. So if you want to talk a little bit about sort of the tips that you learned for writing research.
Right. Yeah. So I remember my first writing sample, my mentor basically changed 97% of it. And this is, I think CJ can probably remember too from grad school,
Yes,
this very commonly. And what I found really helpful was my mentors would basically, when they were writing grants or research papers, they would let me sit in their office and watch over their shoulder as they wrote, and actually speak out loud about how they were formulating their ideas essentially. And this was really gold essentially. It's seeing the writing process play out, and that paired with giving me the opportunity to write very consistently, whether it's papers or grants, that's what really improved my writing. And the thing about writing is it's kind of like art. It's very subjective. So and I always tell my Polygence mentees this, that you don't have to necessarily write like me. We have to write scientifically accurate statements, but the style part of scientific writing is highly individualistic. It's entirely individualistic, actually. It's very subjective, rather. And yeah, so I think the nice thing about academic writing is that once you have someone, and the Polygence mentors are fantastic for this, because I do this with all my students essentially, is that we will start reading papers together, and then I'll try to describe the general structure that these authors are using. And then we start writing, and instead of just marking up their papers, what I end up doing is we will talk through and write one sentence at a time at the beginning. And it's remarkable because these students are much smarter than me. And after one session of doing that, I mean, their writing looks just as good as mine. And these, kids are 10, 12 years younger than me. I always joke that all my Polygence students, I'm probably going to work for one of them, if not multiple of them, by the time that they finish their degrees.
I guess one sort of follow-up question to that would be, for a high school student, maybe a sophomore or a junior, maybe they're doing research right now in high school. Maybe they're in an IB program or an AP capstone research program class. If you had sort of one tip to give them to help improve their research writing, what would you tell them?
I'd say, oh, that's a good one. Yeah, I'd say read a lot of papers and practice summarizing those papers. I think trying to learn how to do a one pager based on a research article, someone did that with me too. Another mentor did that with me, and that really drastically improved my writing.
That's a great advice there, and a great question, Nika. I'd love to segue to your experience at Polygence. And the first question is, why did you become a Polygence mentor? The second question is, I think so far you've mentored 7 students here at Polygence. I could be wrong. I may get that number incorrect, but can you talk a little bit about the Polygence mentees and your Polygence mentees and their projects that they've completed. And this is also a question from Maureen as well.
Right. Yeah. So prior to Polygence, I had mentored about 35 or so undergraduate and advanced degree students, essentially. I wouldn't be here if it wasn't for my mentors. So I knew that when I was during my PhD, I wanted to give back to the scientific community the best I could. So every institution I've been a part of, even when I was at Rutgers as an undergrad, I mentored more junior colleagues. And I took their success very seriously and their growth and learning. I wanted to see people do really well. And that was that is still today one of the most rewarding things about being a scientist, I think, being able to mentor. So when the opportunity came to work with Polygence and reach a broader audience, and at that time I didn't have as many students that were coming in from high school that I had worked with, it felt like a no-brainer to me that I could interact with students that are at this critical juncture in their education, and they might benefit from having an experienced mentor really guide them through a project. And what I try to do for my students is essentially what was done for me at Rutgers, which is create a safe space for them to learn and grow every day, essentially. So, and that's what's been really positive. That's what I mean about my students. It's 7 or 8 of them now. They're amazing. They're going to change the world. It sounds corny and silly, but like I believe that. I wholeheartedly believe that. My students are all much more intelligent than me. They are the kindest people in the world too, and it really puts a smile. Like I can't, so I study emotions, right, and facial expressions, and there's this idea that the face is quite honest because it's not as the voice you can change in some ways to mask your emotion, but the face is a lot difficult, and it's for me, it's very true. It's in many ways, my Polygence students, they made my PhD so much more fulfilling because the time I got to spend with them and see their growth and their accomplishments. It's so special, seeing them publish papers when they're 16 years old. That's amazing. Something that when I was in college, I wanted to publish a paper, and I was very fortunate because of my mentors that I published 3 first author papers. And for me to help facilitate these amazing students to publish papers when they're 16 years, I have one student that has 3 papers actually. It's amazing. Yeah, he basically is getting a PhD by the time that he graduates, high school. It's insane. Another student, I remember she had reached out and she got into her dream college at Penn. And I love like supporting the students too, in terms of, I think the nice thing about Polygence too is that we have that professional relationship with the students, and there's interest on both, for the students to have a reference letter from the mentor and the mentor feels comfortable. I have so much fun writing reference letters for my students. And then when I hear about the success that they enjoy as a result, that's awesome. Another student just sent me his research poster the other day, and it brought a tear to my eye. I thought, gosh, at 16, you did a whole set of experiments that probably could be published. You made a poster based on your research based on some of the things that we worked on together, and you haven't even graduated high school. You can't even drive yet. I think that's one of the most fulfilling things about this, opportunity with colleges that I've had, which is really working with fantastic students and seeing how well they do. And all of my students have placed well, and it's something I take quite seriously. And it's just really nice to work with very motivated and talented and, more than anything else, kind people. The students are just fantastic.
Can you speak to, well, let me sort of phrase this question. So I know a lot of students that are considering enrolling in Polygence and considering having a mentor, that there sometimes confidence can be a little bit of an issue, that like either they haven't written a research paper before, or maybe they have written a research paper previously, or they've done research and it just wasn't a great experience. Can you speak to, because you said this sort of Polygence being a safe space, can you speak to what that means for a student who might be a little bit intimidated with doing research and independent research for the first time?
Right. Yeah, I think that's I always tell my students in the first session, said, the fact that you got into Polygence means you're pretty brilliant. Um, the screening criteria is pretty high. So I tell them that, my job is actually quite easy. I'm just here to help build up your confidence and show you how special you already are, actually. That you don't, I'm just here to give you some tricks and tips on how to, from my 10 years of experience being a scientist, on how we can streamline your learning. So my 10 years of falling and getting back up and learning, essentially, I'm going to try to expedite that for you. There's still going to be some hiccups along the way, learning opportunities. But basically, Polygence is you have someone who's often a graduate student or postdoc, someone that's active in research, most likely, who's doing this because they really want to. They want to interact with high school students and see the future of science be in good hands. Who's going to sit there with you and really focus on what are the things that you're really good at already? What are the things that we need to develop so that we can help you reach your goal, essentially? And in terms of the safe space aspect, this isn't a classroom setting where you get graded or anything. And I tell students that all the time. I said, I'm not necessarily your teacher, I'm your mentor. I'm really like my only goal and like the parameter that I'm optimizing for is your learning and success. That's all I care about, in the sense of, as long as you're learning things, you're going to be, and that leads to your success, and we're doing it in a safe and healthy way that you feel you're not too stressed, your confidence is building, because most of my mentees will go on to make much more important discoveries in neuroscience than I ever will. And the way that I can guarantee that is by making sure they have sound scientific training, but that they're also not burned out by our work together. And I think when those, and that's with my mentoring approach, and knock on wood, so far it's worked. My students have placed well into very good universities. They publish, they all get their projects done, but they all have a research paper at the end. And all of them in the beginning, if you were to ask them, they'd say like, oh yeah, no, we didn't, it felt really challenging to read 50 papers and write this scientific article. And I don't know if it was going to happen. And without fail, all of them do it. And it's because they're all really brilliant and hardworking. And I prioritize at the beginning of every session just to let students share whatever they want to share with me. And it's really an informal and formal kind of mentorship, in the sense of, students will talk to me about, yeah, I'm really worried about this, exam I have coming up. And I feel like I'm not good at math. And I'll say like, well, why don't you think you're good at math? Like, here's like 5 examples that come up, in my head that you did math really well. And then they're like, oh yeah, you're right. Like, I am really good at math. And then 2 weeks later when we meet, they'll say, I did really well on that test. And like, thank you for like reminding me that I'm not bad at math. I'm like, yeah, I mean, that's these little things that, I think is what creates a safe space. Because in the classroom, your teachers sometimes can feel like evaluators and critics in some ways. Your mentor is really your personal cheerleader and coach.
Yeah, that's a great way to phrase it. And I think also, especially now, and this kind of relates back to Swara's question about mental health, that there are a lot of mental health challenges with high school students. And, given we're sort of coming out of the pandemic, and there's a lot of stress about getting, really good grades for, university applications, and Polygence and just mentorship in general is an opportunity for a student to not feel like you have an evaluator sort of the eyes of Sauron sort of like, on you at all times. If anyone has seen Lord of the Rings, you'll understand that reference. But I know we only have about 5 minutes left, and there's 2 more slides. And I just wanted to ask one question here. And the question I have is for anyone who is interested in further exploring neuroscience as a field, and maybe they're considering it for maybe a college major, what are some things that they could do kind of as a first or second step towards further exploring the field? And it could be like resources or just,
Yep.
a couple of bullet points that would be helpful for them.
Yeah, absolutely. So we can send this out. There's a great resource called brainfacts.org. That is a great primer that's actually dedicated to high school students, essentially, to get them exposure to neuroscience. And there's the Brain Facts book, and that is a great starting point for any student. And perhaps we could share that with the attendees after this session.
Definitely.
And yeah, so in terms of a research project like Polygence for a career path in neuroscience, I think Polygence in many ways really gives you a very strong platform to enter college with, in terms of if you are really passionate about research and or STEM in some ways, because you basically, at least the students that work with me, you are getting the level of training that a first or second year PhD student would, essentially. We're going to do detailed literature reviews and write scientific content very professionally. And I tell my students, and what seems like it's working too, is that once they go to college, they don't have any shortage of finding research opportunities once they're in college, because they already have a paper published, essentially, which is a huge leg up. And once they get into the labs, they can hit the ground running because they know the lingo of science already.
Fantastic. And we'll definitely, in the follow-up email, we'll send a couple of resources for folks that are interested in sort of making that first step towards neuroscience. So the last thing that I wanted to talk about, for those in the audience is, if you are interested in moving forward with a research project here at Polygence, it's a pretty straightforward process. And whether this is, you're focused on neuroscience as your topic area, or if you're interested in a different STEM field, or potentially even a non-STEM project like fashion design, we have over 2,000 mentors here at Polygence, and so certainly you could explore pretty much any topic that you'd like. But of course, today's focus is neuroscience. But really, the next step to get enrolled is, if you've already registered an account, all you have to do is jump back into your application and essentially then complete your Polygence application. It's very straightforward. It only takes about 20 to 30 minutes to do. The other option is, if you'd like to get connected with an admissions representative here at Polygence to work through your topic, and maybe try to really drill down what it is that which topic you'd like to further explore in the Polygence program, then feel free to reach out to me at cj@polygence.org. And what I'll do is I'll kick your email over to an admissions representative, and then they'll reach out to schedule an interview with you and help sort of curate your topic area. If you have any other questions about Polygence in general, you're also more than welcome to reach out to me directly. Rahul, thank you so much for being a part of this webinar, and of course answering a lot of great questions here. There's one last question, however, from Lisa, and I wanted to get to this before we sign off. And her question is about Elon Musk's Neuralink. I have absolutely no idea what that is, but take it away if you want to talk about that as we close out our webinar.
Sure. Yeah. I think that's like a great example of things that have been going on, and researchers have been working on basically similar tech as Neuralink for like 20 years now. It's cool to see that private industry is interested in it. I think as a scientist, you just want to see the data, right? So I'm really excited to see kind of what kind of data that they share with the community, and how we can facilitate collaborations, right, between researchers in both academia and private industry like Neuralink, and how to use this really beautiful body of research that people have been working on for 20 years now to advance both how we understand the brain works, but improve patients' lives too. So I'm really excited overall about, in general, the field of systems neuroscience, and the private industry's interest in it. I know some other companies are in the space too. So yeah.
Fantastic. So we're going to close with that. Thank you again, everybody who logged in for our webinar today. I also want to let everybody know that this is going to be a larger series that we're going to be launching sort of as a series of AMAs starting at the end of this month. This is sort of to kick off the AMA series. Rahul, thank you again for your time, and appreciate all the work that you do with the students here at Polygence.
It's a privilege to work with the students and Polygence as an organization, to be honest.
Awesome.
So thank you for having me.
Absolutely. Bye, everybody. Have a good evening. Awesome. I think everybody, and I'll stop the recording as well.